Hello. Hello. This is Eleazar and yeah, that's not gonna work. And Riley. Hi, Riley. And we're doing the water quality testing. Okay. Oops. Sorry, I just bumped something here. And we're gonna do the coliform. Okay. For the coliform, we only have three tests, and they look like this. And there's a little you can read the results on your little low cost water monitoring kit. Okay. But also, there's this card that shows you by color negative and positive. Okay. But I encourage you to read the entire description in the little manual so you can do a proper interpretation. So, what we have decided to do, because we like scaring ourselves, is I, I, I asked Riley to choose the dirtiest water. So we got top two water here. We're gonna use that. Can you choose two more disgusting ones, Riley?
Two more.
And while you're choosing that, I'm gonna go get a Sharpie. So
Upper
I'm gonna
Klamath
pause this for a second so we can both do what we need to do. Okay, so Riley chose the three most disgusting samples. She shows Topsy. You can see hopefully you can see a debris in there. Mmm, yummy. And then this one's Upper Klamath Lake. You can see a greenish tint to that. And what I'll tell you is that this would be very interesting water to look under a microscope because that's full of photosynthetic organisms. So that would be neat. And then we're gonna choose
the
cold
Odessa Cold Springs.
Cold Springs. So the water looks nasty, okay? And what we're gonna do is we're gonna take probably a pasture pipette and transfer those samples to these three containers. So here's the containers right here, and I'm going to go ahead and label these right now. Unless you want to label them, you want to label them? Go ahead and label them, and I'll get pasture pipettes.
Okay,
So,
just from where the water's from?
Yeah, so I'm going to pause this again. Okay, so we're back, and what we've managed to do so far is that Riley has labeled her little containers, and she has also labeled three pasture pipettes with the names. That way we don't cross contaminate anything. Okay, so we're gonna grab the Topsy. Where's the Topsy? Here's Topsy, and here's the Topsy water and the Topsy pipette. And what we're gonna do is we're gonna invert this back and forth a couple times so we have a homogeneous solution. And then we're gonna go ahead and transfer 10 milliliters. So essentially up to the black line. So go ahead, Riley, if you want to do that.
Okay.
So grab your Topsy pipette.
And then how do you open
Oh, what you do is go to the fat side, and there's a little, you can barely, here we go. You can barely grab onto it, like so, and then you pull it apart. There you go.
Okay. Oh, I see. It's like a dropper.
Yeah.
Okay.
Now, yeah.
Get this right open.
And the reason it really doesn't matter what you start with. We started with coliform because we couldn't figure out which test was the coliform. The instructions show an illustration and not a picture, so it was hard to determine which were the tubes for it. But now that we know what they are, we've decided to start with that.
Oh, that's gross.
Yeah, that is gross. Okay, go ahead and put that back in the sheath so we can continue to use it for the same Topsy. And then we're going to go ahead and cap it. All right. So there's our water to the 10 milliliter mark. There's the capsule on the bottom. And now what I'm going to do, because I have I have it here, is I'm going to put this in the incubator. But this has to be incubated at room temperature for 48 hours. So it's 20 degrees Celsius for 2 days. And then after 2 days, you take it out and you take a look at it and you interpret what the outcome is. So we're going to go ahead and do the other two. So Cold Springs. Oh, you did the wrong end,
I did
sweetie.
the wrong end.
Grab a new one.
Okay.
Because you can't resheath this one anymore.
Gotcha.
That's all right. That's why we're learning. Cold Springs. There we go. Yeah, it's hard as it is. And then you're supposed to do it with gloves. May I help? Oh, you got it. You got it. I stopped you just as you got it. I'm sorry.
That's all good.
There we go. Ta-da. Okay, we're going to invert this back and forth a couple times. And we're going to transfer our water, our discussing water. Man, you really made some fantastic choices here. Nicely done.
Sad to think these are places that I've swimmed at before.
Oh, don't tell me that. Oh. Okay, we're going to cap that. See, good resheathing. And then we'll do the third one, the Upper Klamath Lake. Because we need to cap this guy right here. You guys see what we're doing? You can see what we're doing. Good. There's a second one. And you know, by definition, coliforms are facultative anaerobes, which means that they can grow both in the presence and absence of oxygen. However, having said that, they grow faster in the presence of oxygen. So if you just have the cap finger tight so that oxygen can go into it, they'll grow much more quickly. And just to recap, in case you guys haven't realized the significance of this, coliforms are bacteria that are associated with human or animal excrement. So it's stuff you don't really want anywhere around. This one's going to be fun. Okay, this camera is working very nicely. I need to get a microphone, a lapel microphone. A lot of times people can't hear me, just a hair more. And they say that I'm mumbling. I don't think I'm mumbling. I think that they cannot hear me enunciate because the microphone is not very good. Yeah. Okay. So there's our 3 coliform samples. Now I'm going to go put them in the incubator at 20 degrees Celsius. Oh. Watching. Okay, 20 degrees Celsius. Okay, that's set. Now we'll check them in 48 hours, 2 days. And we're gonna pause so we can move on to the next test. Okay, we're back. We're back. It only took us 30 seconds to figure this out.
And there's way more on the table now.
What?
There's way more stuff on the table.
Yeah. Oh, yeah. We'll ignore the fact that there's a whole bunch of stuff on the table. Okay, ladies and gentlemen. Riley? Riley, I'm saying your name correctly.
Yeah.
Right? I apologize. I'm old.
No.
I forget everything.
It's because of the bug.
Because of the bug?
The book. That's why I'm laughing.
I'm not getting it. But here's where we're at, okay? Lamont, the people that made this kit for us, gave us now I can't find the right ones. That's phosphorus, that's nitrate, that's pH, this is oxygen, and this is oxygen. So they gave us 2, 4, 6, 8, 10 capsules times 4. That's 40. And, logically, this makes sense because per test, it takes 2 capsules, right? So the first test is percent oxygen saturation. So that would be, 10 tests there. And then the second test would be biologically available oxygen, or BOD, and there's 10 tests there, right? So there, they did what they needed to do. We have enough to do 10 tests. Here's the hiccup. They provide a whopping 2 bottles. Arguably the silliest thing I've ever seen, okay? And you might think to yourself, well, Eleazar, they mean for you to use the same bottle over and over. Yes, except that if you read the instructions for the BOD, for the biologically available oxygen, you find out that one of the bottles has to be wrapped with aluminum foil for 5 days. And if you do that, that means that you get to do 1 test. So what's going to happen here, ladies and gentlemen, is that we're going to do 1 test. Okay? And to complicate matters more, there's 2 ways to calculate percentage oxygen saturation. Way 1, which is the simple way, is on page 19 of your Lamont book. And on this book, I know you can't see it, but over here we have the temperature of the water in degrees Celsius. Here we have the dissolved oxygen that we find out after we do the test. And where they cross, that's your percent saturation. Now, there's a second way, and we have to pull out our secret decoder ring to use this way. And that's a way that is done on your actual Carolina Biological workbook, okay? How do you do it there? Well, you figure out where your dissolved oxygen is, just like we did before. But now we find the elevation at which that oxygen was found. So let's say that the oxygen was found at Klamath Lake, which is the one that we're going to use. Okay. At Klamath Lake, the elevation was 4140. 4140. So we look at 4140. That's pretty close. So it would be a correction factor of 0.86. So we would take our dissolved oxygen, we would multiply it by the correction factor of 0.86. We come out with a number. Now, Riley's laughing because this is a disaster. Now we put that number, this is on page 11, where it says oxygen parts per million down here. And then we write the temperature at which the water was collected. You draw a line between those two, and wherever it hits this line, that is your percent saturation. So Riley suggested doing it both ways to see how close the answers come. That's scary, but we'll do it. We'll do it both ways. And then for the available oxygen, we're going to calculate the dissolved oxygen in the vial, uncovered, okay? And then we're going to take the same amount of water a second time. We're going to cap it, and we're going to cover it with aluminum foil for 5 days. At the end of 5 days, we're going to test the dissolved oxygen in there, and the difference between the covered and the uncovered is going to be the biologically available oxygen, or the BOD. Okay, so this is kind of complicated. So we're going to go ahead and start this. And the first thing that I'm going to do is get some paper towels because we're measuring dissolved oxygen. That means that we cannot allow any oxygen bubbles in here. If you do, that'll throw the results off. So when you fill your bottle, you have to overfill it. And when you put your cap, if water doesn't run down the sides, then you haven't done it correctly. Okay, so I'm going to get some paper towels so that the water, when the water runs down the sides, we can it doesn't make a mess, because this water is nasty. So let me get some paper towels. Oh, I hope I used to have. Oh, and now maybe not. Okay. There, that should be enough. Okay. So the one that Riley has chosen to do is Upper Klamath Lake. This really nasty one. Okay. So what we're going to do is we're going to take our little guy here. We're going to put it over a paper towel so we can fill in excess. You guys see what we're doing? Is your paper towel? Your little, I don't know if we can.
Stinky.
Stinky?
A little bit.
There we go. Now we're getting something. Okay, so that's all the way to the top. Okay, now, how can I help you? You're doing great, but I don't feel like I'm helping you in any way.
I read the instructions.
How can I get in the way? Okay. So you see how this guy's full, right? It's over full, as a matter of fact. And now we're going to take 2 capsules from the dissolved oxygen, and pretty sure I'm right about all this, but you know what? I hate making mistakes, people. So we're going to drop 2 capsules, and then we're going to cap it. Okay, so go ahead and take out 2 capsules out of there, Riley.
I just push.
Yes, ma'am.
Okay.
Okay.
2 capsules.
Okay, go ahead and put them in there. They're tiny little capsules. There goes one. There goes the second one. Now grab your little cap. The cap is right there.
This is not already overflowed.
And notice that the water is going to run down the sides, and that's what we want. Nicely done. Okay, we're going to make sure that we have a nice tight seal. And now what we're going to do, we're not going to shake it. We're going to invert gently. Okay. How long? The instructions tell us to invert for about 4 minutes. Do you want to time me?
Yeah.
You want to change your gloves so you don't touch your beautiful new phone with nasty Upper Klamath Lake water?
It's okay.
So you're supposed to invert back and forth for about 4 minutes. You don't shake because shaking can cause oxygen to come out of solution. So you just invert gently until the capsules go into solution. And then once the capsules go into solution, we're going to let it sit for 5 minutes to have it resolve completely. Now, my personal concern about this is that the water is not clear. It's got a greenish hue to it. So I'm wondering how difficult it's going to. I don't know. It's working pretty well. Look, I'm seeing a color change already. I get really excited when I see things work, guys. I'm sorry. I love new experiments, even traumatizing ones like this one. Oh, that's working. That's making me so disgustingly happy right now.
There's so many floaties.
Oh yeah. We should probably look at this under a microscope. It'll scare the heck out of you. There's so much nastiness in there. And people go swimming in this stuff all the time. I'm surprised they don't get sick.
Turn into some kind of mutated something or other.
Right? Grow a third eye somewhere. Nothing like watching a movie of somebody tumbling a tube. It's up there with watching grass grow.
It is changing.
It is changing. And not towards a neutral thing. This is changing towards a cool outcome. In real life, the BOD bottles are about that big.
Yeah.
Yeah, and they have special covers on the top so they make hermetic seals.
Ooh.
So that oxygen can't make it in or out. If you can believe it, ecologists, fish and wildlife, environmentalists, these people that care about ecosystems, they do nothing but this garbage all day long.
I mean, to explain to people how bad it's getting.
Not necessarily. No, not necessarily. I mean,
just keep track.
You can't convey to people how an ecosystem is unless you have some kind of basis. So, that is unfortunate that a lot of people think that environmental science is about telling people how terrible we are. But the truth of the matter is that we do a lot of things right. The problem is that we don't choose the right answers all the time. That's where we get in trouble. But we're not always the problem. Sometimes we're the solution. See how there's a little bit of gas developing there? And we can't be worried about that because we were sure that nothing made into the bottle when we went in there. But yeah, if somebody wants to know how healthy an ecosystem is, you have no choice but to do these tests and let them go. Like, for example, you said that you collected some of his water and that it smelled really bad. Well, that's algal growth, and that algae is terrible for the ecosystem because it sucks the dissolved oxygen out of it.
Mhm.
And and who cares? We do,
Mhm.
because I'm telling you, there's people that go fishing and they don't catch anything because the poor fish are dying due to the low oxygen saturation in the water because of the stupid algae.
Mhm.
So we're the first ones to complain, actually.
But the community does a lot with that algae, right?
It is not the right algae.
Oh, gotcha.
Is not the right algae. They're very particular about the algae that they harvest. I know this because one of my mentors, Dr. Moore, who used to be a microbiologist, he went and worked for Desert Lakes Technology,
Yeah.
and they deal with algae. And his job was to do quality control on the autoclaving of the algae so people won't get sick.
Mm.
But
Their little tabs are almost gone,
well, that's the idea.
completely dissolved.
That's what we want: completely dissolved tabs. I was dreading this lab. I was, because this in particular was not making sense to me. I read the whole thing and I'm like, I know that I haven't done it this way before, but this is Chinese to me right now. And look at that, we've got it figured out mostly.
Professionals.
We is professionals. And if you read the book, it tells you that the percent saturation increases at lower temperatures. And that's another problem with global warming, is that as the atmospheric temperature increases and the water becomes hotter, the percent saturation of oxygen decreases. And again, that affects the ecosystem. Beautiful fish that people usually go after, they have a threshold. If there's enough oxygen in the water, they are not going to be able to live in there. And so, that's something that we need to fix. I see them gone. I don't see the capsules anymore.
Yeah.
How are we doing for time?
Well, I forgot to hit start, so.
Well, good. We're
I
done
just
then.
realized.
Okay, so now we have this, right? And what we're going to do with that is we're going to take our handy dandy secret decryptor. See our handy dandy secret decryptor?
Those
And over
pretty
here it
colors.
says dissolved oxygen. So we're going to put this here, and we're going to match it with one of them. Okay? Now, which one do you think it matches?
I don't know. I feel like it's darker than the 4, but not quite an 8.
I will agree with that 100%.
Probably a 7.5.
Ooh, that's pretty rigorous. You're thinking 7.5?
Or 6.
So a
Do we
6?
only use those numbers?
No. We can interpolate. That's what you're doing right now. You're interpolating. So you're saying that this bottle is less dark than this, but darker than this. And 6 parts per million would mean that it's right down the middle. Do you think that's right down the middle?
No. I feel like it's a little darker.
A little bit darker than right down the middle?
Yeah, so 7.
I'm going to agree with you.
Comes up pretty good on the camera. It is a little bit more peach colored in real life. There it is. That's like the true color right there.
Wow.
That is a good camera.
Let me see if I can center it.
That is a really good
I need to pay
camera.
attention to what the camera is doing, because most of the time it's like, do you guys see what I'm doing? But there it is. Okay. So Riley says a 7. I'm going to agree with her. That looks like a good, healthy 7. Okay? So that's what we write down, right? No, now it gets more complicated. That's just where we started. Okay, so remember, now we're going to take our book, we're going to contrast two numbers. So according to page 19 of my book, oh, that's great. See, it doesn't have a match for 7. Now, what was the temperature at which we caught this water?
30.
30 degrees.
Celsius, yeah.
So it's between 53 and 106. That's all right. We can interpolate. So let's see. 5, you have 4, 5, 6, 7, 8. So that's four places, right? 7 is 3/4 of the way there. So what you do is you take 106, subtract 53, divide by 4, multiply by 3, and add to the 53. Riley's looking at me like I'm high right now. Oh, that was so cute. Okay. So.
One more time with the calculator.
Okay. So we're going to take, you guys see that? Probably not. We're going to take 106. We're going to subtract 53. We're going to divide by 4. We're going to multiply by 3. And then we're going to add that to 53. And so it's 92.75. Excellent. We need to write that down somewhere. So according to this chart right here, and our interpolation, the percent saturation of the oxygen is 92.75%. Okay, now we're going to use the other method because we love things complicated. Okay.
97 doesn't sound too bad.
So the other method, what we're going to do is we're going to take our dissolved oxygen. Okay. For us, that was 7. And then our elevation was what, 4,100? Mm-hmm. So that means that we're going to, our correction factor is 0.86 according to page 10. So we're going to take 7 times 0.86 equals 6.02. So 6.02, do you have a pencil? I don't want to write on here with a pen. You have an erasable pen? Mm-hmm. Okay, so we're at 6. We're at 6 in the oxygen in parts per million. That's right there. Now, at what temperature did we collect it?
30.
Okay, here's 30 up here. And now we're going to take a ruler. Sorry. We're going to take a ruler and we're going to connect that 6 with that 30. Just like that. And we're going to cross the percent. I can't see it. I'm going to make it darker. Sorry. 6 to 30. That's better. And according to this, our percent saturation is about 80%.
It's fine. It's just a little off. Just a little.
Actually, that's pretty good. I thought it was going to be way off.
Oh, okay. I thought it was going to be closer to at least 90.
Me too, but that's where it crossed. It crossed at 80, right?
I did the math right on the other one.
Okay, so it's 7.
Oh, not this one, the book.
Oh.
We just did that one, but let me make sure I got the
okay.
97.7.
According to the book, we interpolated
7. Oh, no, we started with the 106.
The hardest part is finding the right page. Okay. So going back to the first method, It was 7 parts per million at 30 degrees. And 7 is 3/4 of the way between 53 and 106. So we do 106 minus 53. We're going to divide by 4. Yeah. Oh, I see what happened. We're going to multiply by 3. And then we're going to add it to 53. 9275. We're correct.
Okay.
So according to this, you're unhappy, aren't you?
Yeah, I thought it'd at least.
You are
be
unhappy.
90.
Okay. How can we make you happier? Okay, take 7 multiplied by 0.86 again. 6.02. So if you, I guess we can say that we're just a little bit to the right here.
Oh yeah, that would put it right about 90.
And now we're going to go to 30. Right, I didn't realize that Riley was this tough.
Like never doing a lab with you again.
I thought you was going to be a pushover. I'm over this. No, I'm just kidding.
There we go. That made all the difference.
Well, we're at 85. You are too demanding, Riley. You're too demanding. Well, which one do you want to go? I think I'd go with this one.
Yeah.
Because
It's the paper protractor.
Because it's the paper. No, because it's what Carolina suggests that we use.
Yeah, I trust them more after that.
I don't know who to trust anymore. Okay, so 85%. I don't know. I'm going to put both of them down. In fact, what I'm going to do is I'm going to do an average of both of them. How about that?
There we go.
We're going to go
85 plus.
I'm going to put both numbers here. So I'm going to go average of 92.75.
Yep. And 85.
And 85.
88.725.
Okay. Now we actually have another piece of information, which is the parts per million of the uncovered tube, which is what? 7 parts per million. So we put that in there. Okay. Now we just need to do the covered tube. Okay.
Aluminum foil.
And that's where we get in trouble. Oh, I've got plenty of aluminum foil, trust me.
Okay.
What we need to do is we need to discard this.
Clean it.
Clean it with distilled water.
Okay.
So we can fill it up with the same thing again.
Okay.
And I'm going to pause the recording because, you know, we're not very entertaining when we're washing dishes. So we're going to stop here. Hello, we're back.
New tube.
The Riley Eleazar group. And we rinse our little tube. You guys see our cute little tube? So we're going to do the same thing as before. We're going to take our Upper Klamath Lake disgusting water. We're going to fill the tube all the way to the top. Okay. The difference is that this time, we're not going to put the capsules in there. Okay. We're going to make sure that it's above the rim, so no oxygen makes it in there. And then once we cap it, we're going to cover it with aluminum foil, and we're going to put it somewhere where it's at room temperature for 5 days. So what I'm going to do, you guys already know that I've got 3 coliforms in the incubator at 20 degrees Celsius. So I'm going to put this with the coliforms, and we'll check the dissolved oxygen at the end of 5 days. Yep, go ahead and cap it. Water should spill to the sides if we're doing it correctly. Make sure it's nice and tight. And then we're going to take some aluminum. Oh, aluminum. That should be enough. Some aluminum. And yeah, we're gonna cover it. And then at the end of 5 days, we're gonna go ahead and test the dissolved oxygen. That'll be the DO for the covered. And then when we subtract one from the other, we'll have the BOD, which is the biologically available oxygen. And we're gonna pause now because we're gonna move to the next thing. Hello, we're back. Riley and Eleazar are doing water quality. We're doing water quality. And we're gonna move over to nitrates. We're gonna do nitrates now. This is not so bad. First, I gotta get rid of all my dissolved oxygen capsules because that's all I can find anymore. I can find it. Nitrate. So here's my nitrate capsules. You're gonna use the C106 test tube. And what we're gonna do is we're gonna put water up to the 5 milliliter mark. Okay, we're gonna put 1 tab in there. We're gonna cap it. We're gonna invert back and forth for 2 minutes. And then we're gonna sit it and let it wait for 5 minutes to reveal. And that should be it. I think these little guys right here are the caps too. So what I would do, guys, is designate each test tube for a different test. So for example, I'm gonna put a little N here. So from here on out, this will be my nitrate test tube. And I'll use it only for nitrates. That way I won't cross it with my phosphate or whatever. So I'm gonna put a little N on there. Can you see me doing an N over there, Riley? Mm-hmm. Am I doing an N? Do you guys see my N? Yes. See my? Yeah. Can you guys see an N in there? Okay. All right. All right. So with a different pasture pipette, we're gonna fill to the 5 milliliter mark. There it is. I'll point to it. I'm hungry. What time is it?
Past dinner time.
Is this information I'll be sharing with everybody that's watching this video, you think?
Oh, okay. I was like, oh,
it's a
no.
new one, right?
No, it's Topsy.
The pipette, is it the one that you use with that water?
Yeah.
Okay, that's what I care about.
Yeah, I was just looking at the Upper Klamath Lake cover whenever I started drawing this.
Okay. Just a hair more. That's good. Perfect. Okay, those are 5 mLs. And I'm going to hold it so it doesn't spill. And now Riley's going to pull out a nitrate tab out of here. Punta nitrate.
And it's going to blow up.
Don't let it blow up. Just going to put it in there. And then we're going to cap it. And then we're going to invert for 2 minutes.
This time I'll start the timer.
Is it me or is that a big test tube?
Unnecessarily big, yes.
The conspicuously large test tube.
I think they gave us all different sizes of stuff in wrong amounts to mess with us.
I don't know. Lamont is actually a very old company. I have used their kits before. It's just that they're all different. If you go to the OSU Extension Service and you ask for the water testing kit, they have a Lamont water testing kit that is more complicated than this one. But it stands to reason, seeing as this is the low-cost water monitoring kit. So you know that everybody's did everything that they could to find the cheapest name they could find.
This is riveting.
Oh yeah, this is right up there with watching paint dry, grass grow, water boil. Oh my goodness.
That water looks so yummy. Like
Yeah.
lemonade.
Okay, Riley. You have now gone too far. It does look disgusting though.
Yeah, this is Topsy.
And where's Topsy again?
On the way out to Kino. Or a little past Kino, actually. Yeah. That one was also stinky.
Wee.
Just make sure. Oh my gosh. Okay, I definitely started it this time and it didn't start.
Okay,
So we're
so Riley hates me and she never starts her cell phone. So now we're gonna let it sit there, and I don't feel like having you guys watch this 5 minutes, so we're gonna pause it. Okay, we're back, and while we were waiting, we labeled another tube pH. pH. Okay, because this is the next test we're gonna do. Here's our nitrate, and there's our solution. I think it's been at least 5 minutes, don't you? So we're going to take our handy dandy decoder card. We're going to put the solution in front of it and see if we can't discern
That's a big number gap.
the nitrate concentration.
I guess it's like a 7 or 8. No, maybe only a 6. 6. It's really close to 5.
Okay, so Riley's saying a little bit above 5.
Yeah.
I agree. Again, a 6, maybe a 7.
Maybe.
You're sticking with 6?
Yeah.
Oops. Okay. So we're going to put 6 on our data sheet for, this is Clemens Lake, is that right?
Yeah.
Okay.
Or no, Topsy, sorry.
Topsy. I don't even have it on there. That's not good. When did we do Topsy? Did we just start doing it?
Yeah, we just started doing it.
Okay. So we're going to do Topsy. Toppsy.
Yeah.
Ppsy. Okay. And let's see, that's line number 3.
Oh, just 1 P.
Oh.
My bad.
No problem. And that's line number 3. And the nitrate we said was a 6. Okay, so we do that in our data table. And now we're ready to do pH. So we're going to move this aside for a second. And let's do the same sample. So let's do Topsy again. Now, this is slightly different. Oh, I can't see my camera. This is slightly different because we're not going to do 5 mLs. We're going to do 10. Okay? So we're going to go up to the 10 milliliter mark, which is way up here. Holy moly.
That's why it's so big.
Do we have enough water left?
Oh, yeah.
Oh, we're doing great. No concerns.
Oh, look at that one. Oops.
Just a tiny bit more. Okay, perfect. Okay, now I'm going to hold it so Riley do not accidentally top it over, okay? And she's going to take one wide range pH tab and she's going to put it in there. Like so. Now we're going to take the cap, put it on there, and then we're supposed to invert until, no, actually it says invert until the capsule disappears.
Okay. You can't really see on the camera how nasty that water is.
It looks pretty messed up. I see a definite color development. Do you?
Yeah, it's turning green.
It's turning green. I think that's very close to neutral if I remember correctly. Red is acidic. Blue is, I think I just messed that up. Red is basic, blue is acidic, and green is neutral, I believe.
Wow, that is like lime green.
Okay. There. You guys see that there's a definite color change? It looks green.
And gross.
Green and gross. Okay. And we compare it to the chart immediately. So somewhere around here, there's a chart. Okay, here's her pH.
Yeah, it's going to be an 8.
It's going to be an 8. So slightly alkaline. You guys see that? I'm sorry. There we go. Almost got it. I can almost do it. Yeah, see that? That's about an 8-ish. Yeah, it looks pretty good. Okay, so that's an 8. So in my data table, I'm going to enter 8 for pH. 8. Okay. Now we have to do phosphates and turbidity. So what we're going to do is we're going to pause here so we can clean our test tubes and get the next one ready. So be back in a bit. Okay, we're back. This one is phosphates. So for the phosphates, we're going to go up to the 10 milliliter mark. And we're going to put 1 capsule in there. Oh, I found it. That's weird. Usually I have to go all over the place looking for these things. Okay, so I'm going to hold that for Riley right about there. Okay, I told you these are the easy ones. The ones that don't make sense, that do not make sense, is the dissolved oxygen because, well, as we discussed earlier, we should have more bottles. It doesn't make any sense to me why we have two.
It's supposed to take 50 days.
You know, if they just gave us like 11 bottles, that would be enough.
That's true. Oh, I got something gross in there. Now, this is the Cold Springs, which from what I am familiar with used to be called the gravel pits.
Okay. Now, is this the one that we've been doing?
Nope, this is a different one.
You switched to another one?
Yep.
That's okay.
I know none. I was just thinking about that too. None of our tests have the same water. It's all
That's not
different
true.
water from all over.
The last three were the same sample.
Oh, that's
Okay, one phosphate. Can't seem to get to the center of the camera. Boop. Put the cap in there. This one we just invert until the pill disappears. Mm-hmm. We got one more after this, which I think is turbidity, and that's a kind of a cool one. Thank you for helping me with this, Riley.
Yeah.
This was.
Thank you for helping me. I didn't want to do all this at home.
You know, I'm not gonna lie to you. This is really boring stuff to do by yourself.
Yeah.
God, that's one of the reasons I don't really like distance education. I mean, I can see 2 or 3 people working on something like this, but doing this all by yourself is so boring.
Kind of daunting too.
It is, right?
Yeah.
You just become overwhelmed and it's like, this is too much work. I don't feel like doing this.
Yeah, there's just certain classes that you really shouldn't have distant ed. You can try to make them as interactive as possible, but it's just not the same.
Yeah.
That's why I always think about the discussion boards. It's hard because it's not a classroom conversation. It's more
Yeah.
like another assignment.
Yeah.
And I love my classroom conversations, so it makes it hard.
Boy, this one's really taking time to dissolve, isn't it?
I think the water was colder. I don't know if that has to do with it dissolving quicker.
I think this one we just read it right away.
My accounting class. That's a class you never want to take online.
Which one?
Accounting.
Yeah.
Yeah, because you have questions in the middle, and depending on when you're doing their homework, it's not exactly feasible to ask.
I want to take a walking class online.
Right?
I wonder how that works out. I should ask Valerie.
Yeah, I have her nutrition class right now.
Oh yeah?
Mm-hmm.
How you doing?
All right. I just did a paper that I worked a whole bunch on, and
I just realized we're recording. You probably shouldn't be divulging how you're doing.
Oh.
Unless you want everybody to
yeah,
know.
I don't care.
Oh, okay.
I'm doing all right. And she just, I just turned in a paper that I worked quite a while on that I didn't do so well, so I'm getting with her to find out where I missed what I did.
Huh.
I like it. It's a pretty cool class. Honestly, I kind of took it because I was like, nutrition, that'll help me lose weight. No, not much of that. Just
Really?
more of like, yeah, it's a lot to do with the diseases if you have deficiencies, or if you have too much. Yeah. Like
I'm
right now we're
surprised.
learning
I'm
about
surprised
vitamins.
because she is all about fitness.
Yeah.
Oh my gosh, yes.
Yeah. Well,
I walk with her twice a week, and she just beats the Hades out of me. She's in very good shape.
the other thing is not meeting your instructors whenever you do distant ed.
Yeah.
There's something to be said about meeting your instructor.
Yep. So this one's supposed to be phosphates.
It's pretty clear.
Yeah. But I actually see a hue, to be honest.
Yeah. Yeah, I can see it. It's the one.
It's the one, isn't it?
Yeah.
That's super awesome. I mean, yeah, I thought it was going to be clear until I put in on the white background.
Yeah.
It's a one, huh?
Oh, yeah. Okay.
I'll be darned.
Yeah, it's hard to tell with that, but cool.
Dun, 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 dun.
There we go.
That's focused.
Yeah, it is.
All right. So that's 1 part per million. And what's the name of this water sample, please?
Phosphate. Oh, sorry. The Cold Springs.
Cold Springs?
Mhm.
So that's going to be number 4. So number 4, we're going to look at phosphates, and that's going to be 1. Okay, now we're going to look at turbidity. So we're going to pause so we can prep for it. Okay, so now we're doing the last one, which is turbidity. And this reminds me, our phosphate got really blue. So you might want to let it sit for maybe 5 or 10 minutes to get full resolution. Look how blue that got. Okay, so that's something that's important. Now, the way that this is supposed to work is that you're supposed to have a 100 milliliter graduated cylinder that comes with your kit, and then you take the base off and you fill that graduated cylinder with the water. But my graduated cylinder was broken, so I had to throw it away. So instead of using a graduated cylinder, what I'm going to end up using is a test tube. Okay, and uh, 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 Riley's the one that noticed this on our little container. If you look right there, it says turbidity test fill line. So what we're going to do is we're going to fill this test tube up to that turbidity line, okay? And then notice that we put that little sticker at the bottom, okay? So we're going to put the test tube on top of that sticker, like so, okay? We're going to look down and we're going to compare what we see with our turbidity markers.
Okay.
So you can either have
Low visibility.
0 or 40 or 100 JTU. So the more turbid that it is, the less that you see, okay? Now, for you guys, if you have a graduated cylinder, you write down the volume of the graduated cylinder of the water that you put on there, and there's a table in the lab. Let me see. The table's on page 13. They turned that water volume into a turbidity. Okay, but again, we don't have that 100 milliliter test tube, so we have to do it differently. So Riley's going to go ahead and fill my test tube here. Fill it up to that mark right there. So we're not going to have a volume because we don't have a test tube. Excuse me. We're not going to have a volume because we don't have a graduated cylinder.
A detachable one.
Well, yeah, a detachable one. It would have helped if mine didn't come broken.
Hopefully that was an anomaly.
Let's hope so. Perfect. Okay, notice that the water line is the same as the turbidity test fill line. So now we're going to put this on top of this. We're going to, sorry, you guys can't see me. We're going to put it on top of that, on top of our little test strip, and we're going to contrast what we see with our turbidity marker. So okay, I've got a number in mind. I'm going to give it to Riley and see if she agrees with me.
Okay. Thinking the 40.
I'm thinking 40. Very nice. I agree. Okay, let's put this back into the original container because that water's completely clean, or not clean, but uncontaminated. So what's the name of that water sample?
Cold Springs.
That's also Cold Springs?
Yeah.
So that's number 4. And water volume, we're gonna put non-applicable. It doesn't apply, but the turbidity is going to be 40. We're gonna save this to my desktop. Yes, I'm afraid of losing it. Boom. We're gonna put Riley. R-I-L-E-Y.
Yep.
Save it. All right. So, ladies and gentlemen, that's the gist of it. If Riley and I can do it, anybody can do it.
Mm-hmm.
So we're gonna stop there. Thank you for your attention, and have a good week. Say bye-bye, Riley.
Bye.